Hi, my name's Addy Pope. I'm a member of the Esri UK education team, and I want to talk to you about climate change and GIS, making climate change data accessible and teachable in the classroom. I'd like to point out that I'm not a climate scientist. This is very much a presentation about a journey that a non-specialist user has to take when they want to access climate projection data. So the brief was that I wanted to create a set of online accessible teaching resources for UK schools that showed climate change in the UK. And I wanted to have resources available at 3 different age groups. And I really wanted to show impact, how climate change was going to impact the UK. Because often climate change sounds like it's something else that happens somewhere else to other people. You often see pictures of polar bears having a long swim and looking a bit thin, or dried up lake beds. It does seem like it's somebody else's problem, but we know that climate change is happening in the UK and our lives will be impacted by that climate change. So we wanted students to have tools which would allow them to explore both national and regional trends in the UK. But when you start getting into it, you quickly realize that climate data is pretty complicated. You need to understand climate models. You need to understand the resolution that those models have been modeled at. You need to understand differences like anomaly and absolute, what RCPs are, and what probabilistic run you want of each model. Once you've understood what you actually need, you can then start downloading the data. And what you'll quickly end up with is a lot of data. If you're lucky, it'll be shapefiles. If you're less lucky, it'll probably be netCDFs. And netCDFs are, they're a file format that most people aren't really familiar with, and they're quite difficult to work with. But you can work with them. And to give you some context, we downloaded about 180 netCDFs to produce dashboards like this. So this is based on about 140 netCDF files to give us temperature and precipitation dashboards. So let's have a quick look at this dashboard in a browser and see what it shows. So we've got the UK CP18 temperature projection data for our baseline period, our mid-century point, and our late century point. And it's an interactive map. So you zoom in on one and the others follow. That allows you to either see the national picture, and you'll notice that these numbers at the bottom are changing, and that's showing the average across the area in the map, but you've also got the UK max and min, and you've got the change from the baseline. So let's come into Glasgow and see what happens. So we can see that in Glasgow, the current temperature, the baseline temperature is about 13.6 degrees, but it's going to rise to 16.4. So Glasgow is going to see an increase in its temperature in the summer. That's mean air temperature. We can change it to be maximum air temperature, and we can also change it from summer to winter. So we're giving the students an ability to really look in depth at seasons, and maximums, minimums, and means. I'm going to swap back to summer, and I'm going to leave it on maximum and come back to a national picture. The final filter is showing the RCPs, 2.6 and 6.0 being a low mitigation scenario at 6, which we're showing now, or a significant mitigation scenario, 2.6. And you can see that the values do change, and most of you will understand why this middle one doesn't change, because the RCP scenarios, the outputs really do diverge after about 2050. But it gives students an idea that there's still something worth fighting for, that we can actually do quite a lot to mitigate the temperature increase by 2100 if we go on a significant mitigation path. But what's nice about this is that the teachers can use them as an interactive tool. They can use them as a front of classroom tool, or they could screen grab this map and get the pupils to explain it from a picture. It doesn't need to be driven interactively, although we would like that. So that's UK CP18 data, it's temperature and precipitation, but what of the impacts? How does the climate change projection, how is it going to impact things like flooding or agriculture, health, energy use, transportation? How are these sectors going to be affected? How would a business or an organization, in my case a student, use the data to understand the impacts? Well, you need to derive risk and impact from the climate data, and unsurprisingly, this in itself is not easy. But fortunately, there's a paper that has looked at this. It was published in 2021, so quite recent, and it looks at changing climate risk in the UK. They've taken the UK CP18 data and they've calculated the risk from a set of sector indicators to create risk data sets which can then be applied by businesses or organisations to better understand the exposure to projected climate change. So let's have a look at what that actually means. Here's a dashboard which is very similar to the previous one, but it's showing rail adverse weather days. So the impact that climate change may have on our railways. To calculate that, you've got variables, you've got thresholds, sorry. You've got maximum temperatures above, when the air temperature is above 25 degrees, minimum temperature is below -3 degrees, or where the daily rainfall exceeds 40 millimeters or the snow depth exceeds 50 millimeters. When you combine all of those four factors together, you get a national picture of rail disruption. And again, we've got this slippy map. So we can look at the national picture, or we can zoom into an area which is going to be adversely affected by climate change. So commuters going into London may experience on average at the moment 31 days of disruption, but by the end of the century that will have risen to 91 days. And this is quite a powerful tool for teachers because it shows that the UK will be impacted by climate change. And again, all the information is there, so it should be self-explanatory, both as an interactive tool or as a screen grab in a handout. Now we could just give the teachers these resources, these web maps, and let them get on with it. But what we've done is we've grouped them together into a portal which is called Teach with GIS UK, and you can see that we've partnered with the Met Office on this climate page. The Met Office's education team has been invaluable. They've really helped us and guided us through the climate data, which was a bit of a difficult task at the beginning. And they've also made sure that the language that we're using is correct as of the most up-to-date science. And without their help, these resources wouldn't be as strong and probably wouldn't be as relevant or used in the classroom. So you can see that we have our 3 key stages. And below that, this is showing, the climate science, and below that we have the climate change impact and adaptations. So a teacher may actually be teaching agriculture, but they may then think, well, why don't I show how agriculture is going to be impacted by climate change in the UK? So they can use it as a standalone. It doesn't have to just be within a climate focus. Let's take a look at one of these in action. So we'll just pick on the secondary exercise. When we click on that, we get the teacher pack, which gives the teacher an idea of the what, the why, and the how before actually launching the lesson plans that the students may want to follow, broken up into bite-sized chunks because actually you don't cover very much in lessons and it may be over a series of actual lessons in the classroom. And if we look at modelling the future UK climate, we can see where that first dashboard that I showed you is embedded. So it gives the students some information about what UK climate projections are, what RCPs stand for, what the different RCPs might mean, before then giving them a dashboard and importantly showing them how to drive the dashboard through a small video. So this is how you give context and you scaffold the learners through quite a complicated subject. And I think it is possible. So if we come back to the slides, in summary, I would have to say it is possible to access climate data and make it reusable as a non-expert. But to do that, you really need to understand how to turn climate data into risk indicator data sets, or in our case, find a paper and extract that data and then use it. Because otherwise it's quite tricky. This task probably needs to be done once and by experts to make sure it's correct. And I think that really is the key to making climate data accessible at scale. And by scale, I mean allowing any organisation to understand their exposure to climate change without having to become climate experts. So in my case study, it's possible to do that and get the information into the hands of both teachers and pupils in schools. So it shouldn't be too difficult for us to work together to try and make that data accessible to any organisation across the UK. Thank you very much. I think we've got time for questions at the end of this section. Thank you.